In this lesson, you will learn how to multiply polynomials together. Just keep the following straight in your mind as you are performing polynomial multiplication. In order to add, you must have like terms. So this would equal 9x. You combine your coefficients and you keep the variable part. Whereas if you were doing 4x times 5x, here you multiply the coefficients as well as the variables. So that means you would keep your base and add your exponents. So your variables will change with multiplication. So if you had 4x squared plus 5x, those cannot be combined by addition. But 4x squared times 5x, that can. That would be 20x to the third. So if you keep these two concepts straight in your mind as you do polynomial multiplication, you'll be just fine. On the screen, you'll see a binomial times a trinomial. So I'm going to show you two ways to do this. Both methods really are just distributing. So I'm going to make a total of 6 multiplications. I'm going to begin by distributing the y to the trinomial, which is going to cause each variable to increase by 1. So I will get negative 2y to the third plus 3y squared minus 6y. Now I'm going to distribute the negative 2, so I'll have 3 more multiplications. So negative 2 times negative 2y squared would be positive 4y squared. Negative 2 times 3y is minus 6y, and then plus 12. And now I'm going to restructure this in standard form, beginning with my highest degree. So my first one is negative 2y cubed. Then I have a 3y squared plus 4y squared would be plus 7y squared. I have a minus 6y and another minus 6y is minus 12y, and then plus 12. So notice again that when I added, my exponents didn't change. This is simplified. My leading coefficient is negative 2, the degree is 3, and this would be a polynomial. It would also be cubic since it is of degree 3. I'm going to show you a second way of doing this. It's going to be a grid method where I use a table to organize my multiplication. So I'm going to need a 2 by 3 table here. So over here on the left I put y minus 2. Across the top I'm going to put negative 2y squared, the plus 3y minus 6. Now, it doesn't really matter whether you put the trinomial along this side and the binomial up here. You can flip-flop them. Now what you're going to do is multiply this and this together and write the answer here. Then you'll do 3y and y, and that answer goes here. So the intersection of the cell is where the row and column header meet. So this will be negative 2y to the third. Y times 3y is positive 3y squared, and then minus 6y. Now I'm going to multiply negative 2y squared by the negative 2 produces positive 4y squared minus 6y and a plus 12. Now you need to combine your like terms, and if things were in order from the beginning, often your like terms are on the diagonal like this. So you're going to add. So I begin with this negative 2y cubed. There's nothing like with that. Then I get a plus 7y squared on that diagonal minus 12y plus 12. So you see that the answer is identical to above. You just do whichever method you prefer. All right, this time I have a trinomial times a binomial. And just my method of choice is I always like to distribute the binomial. So I'm going to do x times each of these. So sometimes kids say I'm doing it backwards, but multiplication is commutative, so it doesn't matter the order. So this will be 3x to the third. Keep my base, add my exponents, minus 2x squared plus 4x. Then I distribute this positive 3 for 3 more multiplications. So I get plus 9x squared minus 6x plus 12. And combine my like terms. So 3x cubed, then I have a minus 2x squared and a plus 9x squared would be positive 7x squared. I have a plus 4x and a minus 6x is minus 2x. And then a constant of plus 12. So this is a cubic polynomial, degree 3, and a leading coefficient of 3, and the constant term is 12. In my third example here, I have 3 binomials multiplied together. So what I'm going to do is multiply 2 of them together, and it doesn't matter which 2. So I'm going to decide to just bring down this x minus 5, and I'm going to make 4 multiplications next. So this will be an x squared plus 3x. Now I distribute the 1 to get plus x and plus 3. And before I handle the other one, I'm going to simplify this to a trinomial. So x squared plus 4x plus 3. And I have this x minus 5 out front. So you can do the grid method, or you can just distribute. I'm going to have 6 more multiplications to make because I'm doing a binomial times a trinomial. So this will be x cubed plus 4x squared plus 3x, and then distribute the negative 5. So that's a minus 5x squared minus 20x minus 15. Combine my like terms one last time, gives me x cubed minus x squared plus 3x minus 20x is minus 17x, and then a minus 15. So I've got a cubic polynomial, leading coefficients 1, and constant term is negative 15. In the fourth one, I have a binomial being cubed. Fight the urge to just distribute that outer exponent. You can't just go like this. That's illegal. You can only distribute an exponent like that when you have a monomial inside. This is a binomial, so you need to expand it 3 times. And this is probably going to get a little bit ugly, but I'm going to multiply 2 of them together first. So I'm going to have 4 multiplications. I'm going to do xy times xy is going to be x squared y squared plus 5xy. So I'm going to distribute there. And then I'm going to distribute this 5. So it's going to give me another plus 5xy plus 25. All right, I'm going to clean this up a little bit. I'm going to have a 10xy here in the middle. Keep my base, add my exponents because it's addition. And I got to bring down this xy plus 5 from the front. Okay, so you should now see you got a binomial times a trinomial, which means you've got 6 more multiplications to make. And you just need to be careful as you make them. So we're going to distribute this xy. All right, so x squared y squared times xy is going to give you an x cubed, because you keep your base and add your exponents, y cubed, plus 10x squared y squared plus 25xy. So if the rules are straight in your brain, you should be able to crank these out pretty quickly. Of course, if you don't know your rules, you recognize it'll be a jumbled mess. All right, now you're going to distribute the 5 to all 3. So that gives me plus 5x squared y squared plus 50xy, and then plus 125. All right, now let's just clean this up. So my greatest degree would be this x cubed y cubed out front. Now I've got a couple things with the x squared y squared. All right, so that's going to be 15 x squared y squared and 75xy. And I got a constant term of 125. So in the end, it's really not all that bad. All right, now we have an application question. Tim has a box with a width that is 5 more than twice the height and a length that is 8 less than triple the height. What is the volume of the box? All right, so I sketched a picture, and I know that the width is 5 more than twice the height. All right, so I'm going to say that the height is going to be my variable. I'm going to make that be my unknown. All right, so let's label this h, the height of the box. And the width is 5 more than twice the height. So the width would be 5 more than 2h, so 2h plus 5. And the length is 8 less than triple the height, so 3 times the height minus 8. Okay, how do we get volume? Well, volume of a rectangular prism is length times width times height. So we are going to do, I'm going to put h out front because it's a monomial, and then I'm going to multiply my 2 binomials together. So it may look really complicated, but reality is this is really not a bad one. So I would suggest doing our binomial times a binomial first. So let's see, that's going to be 4 multiplications. Going to multiply, I'm just going to bring this h down so I don't forget about it. It's going to be 6h squared plus 15h minus 16h minus 40. I'm going to combine my like terms, 6h squared minus h minus 40. And I'm going to bring this h down again. So the volume, once I distribute this h, will be equal to 6h cubed minus h squared minus 40h. So here it is as an expression.